Welcome to video lecture for the subject CS 404 Embedded System Module 5 RTOS based design. Today we will discuss about Micro C OS2, a real-time kernel. So first one is introduction of Micro C OS2. Micro C OS2 is a simple, easy to use real-time kernel. It is written in C language and is used for embedded application development. Micro C OS2 is the acronym for Microcontroller Operating System version 2. So the two main features of Micro C OS2 are, first one is multitasking, that means it supports multi-threading, and second one is priority based preemptive task scheduling. Okay, so the task scheduling model used is priority based preemptive task scheduling model. So these are the two features of Micro C OS2. So this Micro C OS2 is a commercial real-time kernel from Micrium Inc., that is Micrium Incorporated Company. The Micro C OS2 kernel is available for different family of processors or controllers and supports processors or controllers ranging from 8-bit to 64-bit. For example, ARM family of processors, Intel 8085, x86 8051, Freescale 68K series and Ultra Neos 2, etc. are example for some of the processors or controllers supported by this Micro C OS2. Also this Micro C OS2 follows the task-based execution model, and each task is implemented as an infinite loop. So the main services of this Micro C OS2 are task creation and management, kernel functions and initialization, task scheduling, inter-task communication, mutual exclusion and task synchronization, timing and reference, memory management, interrupt handling. So these services will be explained in detail. So first one is task creation and management. So under Micro C OS kernel, the task may be in one of the following states at a given point of time. Okay, so the first one is dormant state, second one is ready state, third is running state, fourth one is pending or waiting state, and fifth one is interrupted or ISR state. Okay, so these are the 5 task states. So first one is dormant state. The dormant state corresponds to the state where a task is created but no resources are allocated to it. This means the task is still present in the code memory space, but Micro C OS needs to be informed about it. Okay, so dormant state means the task is created but no resources are allocated to it. Then second one is ready state. Ready state corresponds to a stage where the task is incepted into memory and is waiting the CPU for its turn for execution. So in ready state, the process or task is waiting for the CPU. Then third one is running state. Running state corresponds to a stage where the task is being executed by CPU. So fourth one is pending state. Pending state corresponds to a state where a running task is temporarily suspended from execution and does not have immediate access to resources. Okay, so this waiting state might be invoked by various conditions. For example, like the task enters a wait state for an event to occur, or waiting for getting access to a shared resource. Okay, so in pending state, the task is temporarily suspended from execution and does not have immediate access to resources. Then interrupted, next state is interrupted or ISR state. So in the state that is interrupted or ISR state, a task enters to this state when an interrupt is occurred and the CPU executes the ISR. So these are the 5 task states. Next one is task creation. A task is usually created as a non-ending function. So here this code represents the creation of a task. Here it creates a task with name micro C task. The task doesn't return anything. That means the return type of this task is void. The argument to the task is passed through a pointer to void. So this micro C task is in the dormant state now. Now you need to pass this task to the micro C kernel to make it ready for execution. Okay, so you need to pass this task to the micro C kernel to make it ready for execution. Now it's in the dormant state. It should be brought to the ready state. It is essential for assigning resources to the task micro C task. The micro C kernel called OS task create or OS task create ext is used for this. Okay, so OS task create and OS task ext function, these are called by the above created task, that is micro C task, for assigning resources to it. So calling these functions allocate the memory for the task and put the task in the ready state. Okay, so this OS task create and OS task create ext functions are called in order to allocate the memory for the task and put the task, that is the task is micro C task, into the ready state. Now micro C OS2 supports up to 64 tasks. Out of this 8 are kernel level tasks and 56 are user level tasks. Each task should have a unique task priority assigned. No two tasks can have the same priority. The priority of tasks varies from 0 to 63, with 0 being the highest priority and of course 63 being the lowest priority. And out of this, the highest priority certain kernel level tasks has high priority, and some of the priorities are already reserved for kernel level task. Next one is what is a TCB, task control block. A task control block is assigned to a task when a task is created. Okay, so TCB is a data structure for holding the state of a task. It is essential for handling the state information during a context switch. And the TCB under micro C OS2 is represented by OS underscore TCB. Okay. So OS underscore TCB represents the TCB, that is task control block. Okay, now some important task creation and management routines supported by micro C OS2 are given. So first one is OS task create function. So this function creates a task and makes it ready for execution. Okay, that is OS task create function. Second one is OS task create ext function. So this function also create a task and make it ready for execution. That is, its function is same as that of OS task create function, but this is an enhanced version of OS task create function. Next one is OS task STK check function, that is OS task stack check function. So this function checks stack overflows for the creation of task. So micro C OS2 does not automatically check for the status of stack on task creation. Next one is OS time DLY function, that is OS time delay function. This function delay the task for the specified duration. So the argument of this function is time duration. So the delay is mentioned in number of clock ticks the clock ticks the clock tick, it ranges from 0 to 65,535 ticks. Okay, so that is OS time delay function. Then next function is OS time DLY HM function, that is OS time delay hour, minute, second and milliseconds function. So this one also delay the task for the specified duration, but the delay time is specified by the combination of hours, minutes, seconds and milliseconds. Then next function is OS time delay resume function. So this function resumes a task which is delayed by a call to either OS time DLY or OS time DLY HM SM function. Okay, so it resumes a task which is delayed by the previous two functions, that is OS time delay function and OS time delay HM SM function. Next one is OS task delete function, that is OS task DEL function. It deletes a specified task. Okay, so this function will delete a specified task. The task is specified by its priority. Okay, so the in micro C OS2, the task priority is considered as the task ID. Okay, and this task ID or priority is specified as a parameter for this OS task delete function. Okay, and this function deletes a specified task with the specified priority or ID. So calling this routine, it places the task in dormant state. So once a process is deleted, the process goes to dormant state. The task can be recreated later if needed by calling OS task create or OS task create ext functions. Then next function is OS task del req, that is OS task delete request function. It is same as OS task del function. It sends a task delete request to the micro C kernel, and this call makes the deletion safe and protects the task from deletion when it is holding shared resources like semaphore and mailboxes. Okay, so if the process is holding some resources like semaphore and mailboxes, it makes the deletion uh, process is safeguarded using this OS task del req method. Then next function is OS task name get function. So this function returns the name associated with a task. The task is identified using its priority. And next function, it is OS task name set function. It sets the name for a task. Okay, OS task names it. As the name implies, it sets the name for a task. And of course, the task is identified using its priority. Then OS task query function, it retrieves the information about a task in a TCB, that is task control block. OS task suspend function. By using this function, it's possible to suspend or block a task from execution. On task suspension, the kernel reschedules the next highest priority task for execution. Then OS task resume function, it resumes a suspended task. Okay, so the task suspended using the OS task suspend function can be resumed using OS task resume function. So these are the important task creation and management functions supported by micro C OS2. And the second one is kernel functions and initialization. So the kernel, the micro C OS2 kernel needs to be initialized and started before executing the user task. So the micro C OS2 provides OS kernel initialization and start routines for this purpose. So the OS kernel initialization function OS init is executed first. Okay, so the first function executed for kernel initialization is OS init function, that is OS initialization function. So this function, that is OS init function, it performs the following two operations. First one is it initializes the different kernel data structure, and second function is it creates the idle task OS idle. Okay, it creates another task, an idle task called OS idle. So this OS idle task, it is the lowest priority task under the micro C OS2 kernel, and it is executed to keep the CPU always busy when there are no user level tasks to execute. User tasks are not allowed to delete or suspend this idle task, that is OS idle task. Okay, so here this code represents the implementation of OS idle task, and here you can see this OS idle task. It simply increments a counter to keep the CPU always active. Then the next function used in the initialization process is OS stat init function. Okay, OS statistical initialization function, that is OS stat init. So the micro C OS2 kernel runs a statistical task for computing the percentage of CPU usage, that is called OS stat init function, and this task should be executed before the OS start function, where the OS start function, it starts execution of high priority task from ready list, and it enables multitasking. So the code for OS initialization and start operation is given here. So void main OS init, then OS start. So this OS init function, it calls OS statistical initialization function that computes the percentage of CPU usage. Okay, so first OS init function is executed, then OS start function is executed. So these are the kernel initialization functions used in micro C OS2. Then third one is task scheduling. The micro C OS2 support preemptive priority based scheduling. Okay, so preemptive priority based scheduling. So as we know, each task has a priority ranging from 0 to 63, where 0 being the highest priority level and 63 being the lowest priority level. Out of this, the 4 highest priorities, that is 0 to 3, and the 4 lowest priorities, that is 63 to 63 minus 3, are reserved for the kernel. That is 8 priority levels are reserved for kernel level task, and remaining priority levels are for user level task. When the kernel starts, it executes the first available highest priority task. A task rescheduling happens if any one of the following situation occurs. So first one is high priority task becomes ready to run, or when a task enters the waiting state. Okay, so whenever high priority task becomes ready to run, or when a task enters the waiting state due to the invocation of system calls like OS task suspend, OS task resume, OS task delete, etc. That is the first case. And second case is whenever an interrupt occurs. Okay, so whenever an interrupt occurs, the tasks are rescheduled upon return from the interrupt service routine, that is ISR. Okay, and the in micro C OS2, the task scheduling happens at two levels. One is task level and second one is ISR, interrupt service routine level, that is ISR level. Okay, so the task level scheduling is executed by the kernel service OS underscore SCHED, that is OS underscore schedule, when a system call occurs. Then for task level scheduling, the software interrupt OS underscore task underscore SW is triggered and the context switch handler OS CTX SW is executed as ISR for this interrupt. Okay, so OS schedule function, it initiates the task level scheduling, and OS task SW is a software interrupt which is triggered and the context switch handler OS CTX SW is executed as ISR for this interrupt. So the service OS CTX SW is part of the micro C OS2 kernel service and is responsible for handling the context switch operation. So this function, it saves the CPU registers and PSW. PSW is program status word to the stack of the preempted task and loads the CPU registers and PSW from the stack of the highest priority tasks. That is the process of context switching. Okay, so context switching is carried out by this OS CTX SW task. Now, second level is ISR level. The ISR level task scheduling is done by the function called OS int exit. OS int exit function. When an OS int exit function call is executed, the kernel is notified that the ISR is complete and the kernel checks whether there is any high priority task is ready for scheduling. If a high priority task is ready for scheduling, the ISR returns to the high priority task instead of returning to the interrupted task. Okay, so the function call used is OS int exit function. Now it is possible to lock a scheduler so that the task rescheduling will not take place if the scheduler is in the locked state. The scheduler can be locked by invoking the system call OS schedule lock, OS SCHED lock function. Proper care should be applied in the usage of this function because once the scheduler is locked with this call, the application should not call any other function calls which suspends the execution of the current task. And since the scheduler is in the locked state, it will not be able to schedule another task for execution and the current task is already in the suspended state. That means the system hangs up. Okay, and another function is OS SCHED unlock, OS scheduler unlock function. It is used to unlock a scheduler. Okay, so the scheduling can be resumed by calling this function. And another function is OS task change priority, PRIO. Okay, that is OS task change priority. So the priorities associated with a task can be changed dynamically by using this function. So this function takes current priority and new priority as arguments. So these are the functions used for task scheduling in micro C OS2 kernel. So the remaining services, so we have discussed first three services in this video. The remaining services will be discussed in the next video. Thank you.